All right, everyone, we are starting some more geometry, surface area, and we'll soon move into volume. We're starting with cylinders, but before we even start with cylinders, we need to get to know the circle again. As you can see here, I have plenty of cylinder, real-life cylinder examples. Here's some more, and our last one, this coffee mug here with some dimensions on it. And these are all things that you see around your house probably daily. And if you want to write down on page 309 or in your notebook the formula for the surface area of a cylinder, you can see it here. And you can see that if we took apart a cylinder, it is made up of two circles and a rectangle. If you want to sort of picture that, you can picture this SpaghettiOs can. The top is a circle, the bottom is an identical circle, and if we peeled off this label, it would be this rectangle. Before we get into the surface area of cylinders, we're going to focus just on the area of circles and really understand what pi r squared means. So if you want to, again, use the space here, you can, and then tomorrow's video we will look into surface area of cylinders. So here we go.
But before we can learn those things, we first need to learn about pi. Grog made pie. Sorry, Grog, not that kind of pie. In math, the word pi, which is spelled P-I, refers to a very special number. In fact, it's so special that it gets its own symbol. This Greek letter here is the symbol for the number pi. But if pi is just a number, why don't we write it like that? Why do we need to use a special symbol for it? That's a good question, and I'll get to that in just a minute. But first, let's learn what pi really is by seeing how it relates to a circle. It turns out that pi is really a ratio. Now, if you're not sure what a ratio is, you can watch our video about it. But basically, a ratio is just a relationship between two numbers that's written like a fraction. Pi is the ratio of two different distances on a circle. It's the ratio of the distance around a circle to the distance across a circle. And what do we call those two distances? Yep, the circumference and the diameter. So pi is the relationship of the circumference to the diameter. And as you'll see in a minute, because pi is a ratio, it's the same number for any circle, no matter how big or small. Okay, but what number is it? What's the value of pi? Well, to figure that out, have a look at these two circles, one big and one small. We're going to imagine that our circle's diameters are flexible like a piece of string, and that we can wrap them around the outside edges, circumferences, of the circles. So for each circle, if we start at the top and wrap the diameter around the circumference, we see that one diameter is not enough to go all the way around. So let's get another diameter and keep going where the first diameter stopped. Two diameters still isn't enough to go all the way around. It looks like we're going to need to get a third diameter and keep going. Oh, so close. 3 diameters is almost enough, but it looks like we're going to need just a little bit more to form a full circumference. That little bit more turns out to be about 0.14 diameters. That means that it takes 3.14 diameters to equal 1 circumference for any circle, big or small. So the value of pi is always 3.14. Well, okay, pi is a little more complicated than that. 3.14 is really just pi rounded off to 2 decimal places. And we actually have to round pi off because it's a type of number that's called irrational. An irrational number has decimal digits that never end and never repeat.
Sort of crash course in pi. I just wanted to remind you that this note page is available to you for the next video. It is titled Circumference and Area of a Circle, and there's space for the formula and some practice problems. So if you can print that, great. If you can't, you can set up your page to look like this, or you could make a copy of it and sort of write in here if you want. It's up to you. But this is available to you on the documents that I shared with you on Monday. Here we go. Circumference and area of circles.
The formulas that we use to calculate circumference and area are so important that you should really memorize them. To help you do that, we're going to look at them side by side, and that will help you see their similarities and their differences so you don't get them mixed up. The formula for finding the circumference is circumference equals pi times diameter. And just like most formulas, we use abbreviations. C for circumference and D for diameter. So that's a pretty simple formula. It tells us that if we know the diameter of a circle, all we have to do is multiply that diameter times the number pi, and we'll get the circumference. And we'll try that formula out in a few minutes. But first, let's see the formula for area. The formula for finding the area of a circle is area equals pi times radius squared. Again, we can use abbreviations to make it shorter. A for area and R for radius. Now this is a pretty simple formula too. It tells us that if we know the radius, we just have to square it and then multiply that times pi to get the area. Okay, but what does it mean to square the radius? Well, squaring a number just means multiplying it by itself. For example, 3 squared just means 3 times 3. And 5 squared just means 5 times 5. And r squared just means r times r. So our formula is really just area equals pi times r times r. But we write it in the r squared form because it's more compact. Oh, and one really important thing to keep in mind is that r squared is not the same thing as 2 times r. That's a common mistake that students make when first learning how to find the area of a circle. And if we look carefully at both of our formulas, you'll see why. These two formulas have a lot in common. In each of them, you're multiplying pi by part of a circle to find either the circumference or the area. In the case of the circumference, you're multiplying pi times the diameter. And in the case of the area, you're multiplying pi times the radius squared. But do you remember the relationship between the radius and the diameter? Diameter is just 2 times the radius. So we could rewrite our formula for circumference like this. Circumference equals pi times 2 times r. Ha! Now you see why it's so easy to get confused. To find the circumference, you take the radius and double it. Then you multiply by pi to get the final answer. But for area, you don't double the radius, you square it. And that's a very important difference. To help you see that difference in action, let's find both the circumference and the area of this circle using our two formulas. The only thing we know about this circle is that the radius is 8 meters. Luckily, that's all we need to know. First, we use our formula for circumference. Circumference equals pi times diameter. To get the diameter, we take the radius and we double it. That is, we multiply it by 2. 2 times 8 equals 16. So the diameter is 16 meters. Then, we multiply that by pi to get the circumference. Since this is decimal multiplication, I'm going to use a calculator. 16 times 3.14 equals 50.24. So that means that the circumference of this circle is 50.24 meters. All right, now let's find the area using our formula, area equals pi times r squared. Again, we start with the radius, but instead of doubling it, we square it. That means we multiply it by itself. 8 meters times 8 meters equals 64 meters squared. Then we multiply that by pi. 64 times 3.14 equals 200.96 meters squared. That's the area of this circle. As you can see, the result we get when we square the radius is very different from the result we get when we double it. And one of the most important differences is with the units of our answer. Doubling the radius just gives us the diameter, which is a one-dimensional quantity. So the answer we get from our formula for circumference is also a one-dimensional quantity. But when we square the radius, that gives us square units, which are two-dimensional. That makes sense because area is always a two-dimensional quantity. Remembering that will help you avoid getting these two formulas mixed up. The one that has the radius squared is always for area. All right, let's try a couple real-world examples to make sure you've got it. Here's the real world, which, as you probably know, is a sphere. But if we take a slice of the world right at the equator, that slice is a circle. Let's find the circumference of that circle. To do that, we need to know the diameter of the Earth. That turns out to be about 12,750 kilometers. Great. Then to find the circumference, we just need to multiply that diameter times pi. Now I'm definitely going to use a calculator for this. And I'm going to use a more accurate version of pi, since this is such a big distance. So 12,750 times 3.14159 equals 40,055 kilometers to the nearest kilometer. Wow, that's a pretty big circumference. No wonder it takes so long to go all the way around the Earth. Your mark, get set, go! Whew. Yes! 3.14 seconds quicker than last time. Yes! Whew. Here's another real-world example with a circle. If this pizza has a diameter of 24 inches, what's its total area? Well, using our formula, we start by squaring the radius. But the problem didn't give us a radius, it gave us the diameter. So we have to calculate the radius from the diameter. Fortunately, that's really easy. The radius is just half of the diameter. So we just need to divide the diameter by 2. 24 inches divided by 2 gives us 12 inches for the radius. And now that we know the radius, we need to square it. 12 inches times 12 inches equals 144 inches squared. Next, we just multiply that by pi. 144 times 3.14 is 452.16. So the total area of the pizza is 452.16 square inches.
I just wanted to walk you through one. So if you printed out the notes page that I referred to earlier, great. If you didn't, just copy this down in your digits or notebook. A circle with a radius of 6 inches. So again, a circle with a radius of 6 inches. We're going to first do the area. So area equals pi r squared. Our r is 6. Our pi is 3.14. So we're substituting in 3.14 for pi, 6 for our r or radius. And we multiply all that together. So basically 3.14 times 36, and we get the area 113.04 inches. Now, for the same circle, I want to go ahead and calculate the circumference, which is just the perimeter of the circle. So that formula is circumference is pi times diameter. We're not given the diameter, we're given the radius. So we're going to double it. So when we see this in our formula here, we're going to see, oops, I have an A here. This should be a C. Circumference equals 3.14 times 12. How did I get 12? I just doubled the radius to get the diameter. And, oh, there's that A again. Circumference then is equal to 37.68 inches. And remember that this is not squared. Your area is squared, your circumference is just a distance. So go ahead and try the practice problems assigned to you now. Tomorrow we will move into finding the surface area of cylinders, which, if you remember back, is made up of 2 circles and 1 rectangle. Good luck!